Hello, everyone. This is Justin Gu with another question from the 2009 School Sprint Round. Today, we're going to be working on question 26. I'm currently not at the usual device that I record on, so apologies if any of the formatting is changed and if that bothers you. So let's get right into the question. So we have an isosceles trapezoid with the side lengths as shown, and we need to find the length of segment AC. So I've already taken the liberty of pre-drawing some lines that we can use to actually help solve. So since we need to find segment of AC, and we only know the outer sides, we therefore know that we have to be able to relate the sides of the trapezoid to segment AC, right? If we look at AD and DC in relation to AC, we see that that forms a scalene triangle, and it's going to be pretty hard to work with that. However, what we notice is that AC actually forms a right triangle if we divide up the side length AB, and we can sort of use that to solve. So let's get right into it. So we know that AB is 21 units long, and we know that DC is 9 units long, right? So therefore, we know that the AD, length of AD plus the length or not AD, sorry. We know that the difference is going to be important here, right? So let me find a way to show this. Apologies for my handwriting in advance because I'm using a mouse pad, right? So we know that if we find this length down here, we should be able to find the remaining length of the rest of the segment, which I will paint in gray. Right. However, in order to find the length highlighted in blue, I have to subtract AB. I have to subtract DC from AB, right? So first, let's do a subtraction, right? So we have 21 minus 9, which will equal 12, right? So it gives us 12. However, when we think about this, this isn't actually just the length of the blue segment here, right? It also includes this red segment that I'm about to line, right? It also includes that segment. And we know this because um, we went in the lines, right? Our lines here. Um, we can see that those two segments go beyond the side length of DC, and so therefore we have to account for that, right? Luckily for us, I don't know what my text went. So we know that AB minus DC is equal to 12. And so we also know that this bottom red length and this blue length are the same value because they share the same hypotenuses and the same heights. So therefore these two lengths have to be the same, right? If you look at them, they're congruent right triangles. So because we know this, we can actually just divide this value by half in order to get the length of the blue segment. So if we take 12 divided by 2, we will get a value of 6, right? Cool. All right. So now that we know this blue length, we can actually use that to find the length of the vertical line that I've drawn, right? So if we know that this side is 6, give me a second, add it right in. So we know that this side is 6, right? We know this side is 6, we know the hypotenuse is 10. And so for those of you who remember, actually, I'll do it out. We'll do a Pythagorean theorem out. This is also a Pythagorean triple, but we'll solve it out for you guys. So right, I will treat 6 as my A value, so I have 6 squared plus B squared will equal C squared, which is 10 squared. So 10 squared, right? I will now I'll now simplify all my square roots. So I have 36 plus B squared equals 100. Right now we'll subtract 36 from both sides. So B squared is equal to 64. And hopefully you guys all know that 64, the square root of 64 is 8. So we know that B is equal to 8. Right. So now that we know the length of B, this vertical line, I'm going to write it in here. This length is 8. Right. So now we need to find the length of this gray segment down here, right? So since I know the length of the blue segment and I know the length of the entire line AB, I can just do some quick, easy subtraction to do that. To find the length of that big gray segment, I'm going to have 21 minus 6. That gives me 15, right? And so we know that this bottom segment is going to be 15. So it's just another case of the Pythagorean theorem. This time we don't know the hypotenuse, we know the two side lengths. So we're going to have 15 squared plus 8 squared is equal to c squared. Now we're going to solve this out. So 15 squared is 225 plus 64, which is equal to c squared. Now you sum these together, 225 plus 64 is equal to 289, which is equal to c squared. So hopefully, again, this is another one of our squares. 289 is actually 17 squared. So, right, so we want to see equal to 17. If you guys don't know this, what you can do is that you can recognize that so we know 15 squared is 225, and we know 20 squared is 400. So we know that it has to be somewhere in between those two values. And so you can use that to narrow the range and sort of guess and check a little there. But ideally, you do know all your square values. So since we now know that our C value is 17, we know that the length of AC is going to be 17 units. And just put that right there. Yep, that works. All right.